everyone, this is Dr. CJ Tak, and today we will discuss classification of colloidal dispersion in the subject physical pharmaceutics 2. So, the colloidal dispersion that is classified into three types: lyophilic colloids, lyophobic colloids, and association colloids. We will see one by one. Lyophilic colloids. Lyo means solvent, philic that means loving. So, the meaning of lyophilic colloids that is solvent loving. Here, the disperse phase having the greater affinity towards the dispersion medium, and the dispersion medium it will form one of the solvent sheet around the colloidal particles. That's why this lyophilic colloids that is thermodynamically stable. The lyophilic colloids that is easy to prepare and they are reversible in nature. It means colloidal particles can be reconstituted after the purification steps. Here in lyophilic colloids, it includes dispersed particle and dispersion medium. Dispersed particle, they are of two types, hydrophilic and lipophilic. Hydrophilic, it includes acacia, gelatin, albumin and insulin, whereas the lipophilic, it includes the rubber and polystyrene. As a dispersion medium, water and organic liquid can be used. If water is used as a dispersion medium, then it is known as a hydrophilic colloidal dispersion. And if we take organic liquid as a solvent or as a dispersion medium, then it is known as a lipophilic colloidal dispersion. For example, rubber and polystyrene, if we dissolve in a benzene and ethyl methyl ketone, then it is known as a lipophilic colloidal dispersion. Then lyophobic colloids. Lyo that means solvent, phobic that means hatting. Here the meaning of lyophobic colloid that is the solvent hatting. Here the disperse phase and dispersion medium in between there is a very little attraction. Here the charge is present on the particle, so that we can say the system that is in a stable bond. Here the like charge that is present in between the particle which shows the repulsion. Due to such type of repulsion, the particle will be away. It will maintain the distance in between the molecules, even though the situation it will be in a stable bond. Here the solvent sheet that is not present, so that the lyophobic colloids that is thermodynamically unstable in nature. If we use water as a dispersion medium, then it is known as a hydrophobic dispersion. Gold, silver, sulfur, arsenic sulfide and silver iodide in water, these are the example of hydrophobic dispersion. Different method of preparation for the lyophobic colloids. Mainly two methods are there, dispersion method and condensation method. We will see these methods. First one, dispersion method. Here the colloidal particle, or we can say the coarse particle that is converted into the colloidal size end. In that first one, that is the milling method. The substance, or we can say the disperse phase, that is finely grounded by usual method, or that we can use the mortar pestle, and that is added to the dispersion medium and coarse suspension is prepared. Then afterwards, the size reduction that will be initiated by the colloidal mill. The colloidal mill, it contains two steel discs having very small clearance in between them. The disc it will rotate at very high speed in opposite direction. When the material it will pass through the colloidal mill or between these two discs, the coarse particle it will be converted into the smaller size particle of desired size. We can repeat the same process until the desired size is obtained. Here in this process we can use the stabilizer also. The stabilizer it will facilitate the size reduction to achieve the fine state of subdivision of the colloidal dispersion. Here the example is given colloidal sulfur that can be made by grinding the sulfur with the sucrose or lactose. Here the sucrose or lactose, that is the example of stabilizer. Other stabilizing agents are gums, gelatin and soaps. In pictorial view it has been given that coarse particle that can be converted into the colloidal particle with the help of milling or grinding. Then peptidization method. Breaking up of aggregates or secondary particles into the colloidal size, that is known as the peptization technique. Here the peptizing agent is used. It promotes the dispersibility of the solids without entering into the combination as a product. Glycerin, sugar, lactose and acid containing hydroxyl group such as citric acid and tartaric acid, that are the example of the peptizing agent. Here in the figure we can see, once we have the plots of the aggregates, by removal of the electrolytes or by removing the flocculating agent, it can be converted to the colloidal size range or colloidal particles. Same way, the another technique, addition of surfactant or addition of deflocculating agent, it will convert the flux or aggregates to the colloidal particle size range. So this is about the peptization method of dispersion. Then electric arc method. Electric arc method is used for the dispersion of gold or silver. Here the intense electric arc is produced in between the two metal electrodes. Here the two metal electrodes that is used and under the surface of cold water. Due to this process, the heat will be generated in between this, and such a heat, it will release the metal as a vapor which condenses to the colloids and stabilized by the KOH in a cold water. By such a techniques, we can have the dispersion of the gold or silver. Then ultrasonic treatment. With the help of ultrasonic waves, we can initiate the cavitation and compression in the dispersed phase. These cavities will collapse with the great force and cause the breakdown of the coarse particle to the smaller size particle. Here also we can use the surfactant as a stabilizing agent which can prevent the reunion of the dispersed particles again to the coarse particle size. The next technique, that is the condensation method. In condensation method, we need to prepare the supersaturated solution. If we add solute in exceed amount into the solvent, then the supersaturated solution will be obtained. From this supersaturated solution, if it produces the precipitation or crystal growth, then by this method we can have the colloidal dispersion. So in this method, the crystallization technique it will be used, which is divided into two steps, nucleation and growth of nucleus. Here the molecules in the solution, it will be nucleation will be initiated and the nucleus of the colloidal particles will be obtained. Then afterwards the crystal growth will start. Here the ions and molecules from the solution, it will slowly get adsorbed on the nuclei that has been formed previously in the nucleation process, and it will grow to the size of the colloidal dimension. So by this technique we can have the colloidal size range of lyophobic colloids. The methods, one of the method over here to prepare the colloidal particle, that is the addition of non-solvent. In this method, alcoholic solution of sulfur, if we add water, then it will solve the precipitation of sulfur. In a pictorial view, we can see, for example, if we have sulfur, we have added this sulfur into the solvent, we can say the alcohol. Now we have the molecules of the sulfur in a alcohol in a solution form. If we add water, which is a third substance to this, if we add water into this, which has the higher mutual solubility with the alcohol, so in such a condition, the sulfur will be precipitated out and it will form the colloidal particles of sulfur. So by addition of the non-solvent, here as a non-solvent we have used water. But due to the mutual solubility in between the alcohol and water, the sulfur have been precipitated out. And by this technique, we can have the colloidal dispersion of sulfur. Then by the chemical reaction, for example, if we have reactant A and we have mixed with the reactant B in a solution, and by this technique, we can have the colloidal particles. Such a reaction, they are the reduction, oxidation, hydrolysis and double decomposition. By this technique, we can obtain the colloidal dispersion of different substances. Then association colloids. Here the association colloids that is prepared with the amphiphiles. These are the ions or the molecule which have the affinity for the polar and non-polar solvent. This is the figure for the amphiphils, which contains polar head and non-polar tail. Polar head, that is hydrophilic in nature, whereas the tail, that is hydrophobic in nature. If in water we add low concentration of the surfactant, which will act as a monomer, we can see this in a figure. This substance, this amphiphile, they will act as a monomer and they will arrange at the interface, and here the surface, that is unsaturated. If we add more surfactant, if we add more amount of the surfactant concentration, then surface will be saturated and they will form one of the monomolecular layer. This will be the amphiphile concentration equals to the CMC, that is known as a critical micelle concentration, and in this case surface will be saturated. The same things we can see in another figure. For example, if you have added the small amount of the surfactant in water, then surface, they will start to initiate it at the surface. Then afterwards, if we add more amount of the surfactant, then they will go to the bulk. And even if we add more amount of the monomer, or we can say amphiphile, or the surfactant in the solution, then it will start to form one of the aggregates and it will achieve one of the spherical shape, which is known as a micelles. This micelle contains 50 monomers and the size of the micelle, that is nearly 50 angstrom. So this is the concentration at which the micelle starts to form, that is known as a critical micelle concentration. This is critical micelle concentration. It gives the concentration range of the surfactant at which micelle starts to form. It has the unit of concentration such as weight by weight, weight by volume percentage, moles per liter, moles per 1000 gram of solvent. Now the behavior of the surfactant molecules in aqueous and non-polar media. Near CMC, micelle, it will achieve one of the spherical shape. Now in this condition, if we consider in a polar substance, if we consider in water, then the tail, it will faces toward the center and it will create one of the hydrophobic environment, or we can say it will create one of the hydrophobic pocket. In case of non-polar solvent, if we add surfactant in a non-polar solvent, solvent, then the reverse effect will be seen. In non-polar dispersion medium, the opposite behavior, that means hydrophilic pockets, it will be formed. Then the dynamic equilibrium of micelle in aqueous medium at high concentration of amphiphils. For example, if we add sodium lauryl sulfate, initially we have seen the monomer at the interface. If we add higher concentration of the surfactant, then the spherical micelle will be achieved. Then even at higher concentration of the amphiphils, the laminar micelles, it will be formed in our solution. So association colloids, it will give the favorable environment for the solubilization of poorly water soluble drug. So this was about the association colloids. So in this video, we have discussed about the lyophilic colloids, lyophobic colloids, the method of preparation, dispersion method, condensation method, and association colloids, which includes the monomer, micelles, CMC, hydrophilic pocket, and hydrophobic pocket. So this was about the classification of colloidal dispersion. Thank you for watching this video.